Have you ever gone to toast a piece of bread and wondered how the toaster worked? Well, wonder no longer. In this PowerPoint, you will learn how dynamics plays a role in the mechanisms of a toaster and what truly happens to your bread inside that toaster. So what you just saw were a series of videos showing how a toaster works from the side and top views. On these next few slides, we will show the basic internal mechanism in the toaster that will be represented by free body diagrams, energy diagrams, and mass velocity diagrams, since this toaster is an example of a work energy and conservation of momentum problem. So for the initial conditions of the toaster, the assumptions you have to make are that the spring has negligible mass, the spring starts and ends at its natural undeformed length, the toaster and the bread together are in a closed system, and the energy that is supposed to be lost to heat and sound are negligible. The toaster has potential spring energy due to the compression of the internal spring beneath the lever that lowers the toast. So therefore, the spring compresses from x1 all the way to x2, and the equation used is V equals 1/2 kx squared. This is the elastic spring potential energy equation. After the timer stops, the latch keeping the spring compressed is released, which transforms the potential energy into linear kinetic energy, since the bread only moves in the y direction. And the equation shown, T equals 1/2 mv2 squared, is the kinetic energy equation, and the spring thus moves from x2 to x3. Since this is a conservation of energy problem, the potential energies are equal to the kinetic energies, and what we're left over with is the elastic spring potential energy equal to the kinetic energy at the end when we're all done toasting the bread. So you set 1/2 kx squared equal to 1/2 mv2 squared, mv2 being the velocity of the bread. Since the halves cancel out, you're left with v2 equals rad kx squared divided by m. So as you can see in position 1, the spring is compressed and is deformed. And in position 2, it's released, so it travels up with the velocity v2. And then in position 3, it goes back to its natural undeformed length, but however, the bread acts like a projectile and is shot upwards at velocity v3. This is a conservation of momentum problem because it is a closed system. So for the MVD, the start one, it starts in position 2 with mt plus b v2 as going up. And then at the end, it's mb vb3 at position 3, and velocity of t3 is 0, meaning that at the end, the toast is the only one that has velocity, whereas the toaster surface inside has 0 velocity. This is the problem written out in equation form, so you set the initial equal to the final and plug in all the variables from the MVD into the equation. So for V2, you substitute in rad kx squared over m from the work energy equation. And from there, you solve for the final velocity of the bread, VB3.